The risk and potential harm of gene therapy outweigh its benefits. As technologies advances in the field of healthcare and causes the advancement of gene therapy. As we all know, there are a lot of benefits to gene therapy. It can cure some kinds of diseases that no other medication can cure and can treat or prevent diseases, including cancer, genetic diseases, and infectious diseases. It can give many people a better life. But it has its own risk in curing diseases. It may cause some infection by activating some of the viruses in our body, and it might be dangerous if it turns into defective cells. Instead of preventing diseases, it can cause risks such as cancer and damage the organ. Just like the another medication, we can't really say that nothing infallible will happen, and it may have unpredictable risks that follow. We must be aware of the risk and potential harm that gene therapy causes.
The key benefits of gene therapy is its ability to target the root cause of genetic diseases rather than just managing symptoms. By producing healthy genes or modifying existing ones, gene therapy has the potential to provide long-lasting or even permanent solution for certain inherited disorders. This can greatly improve the quality of life for individuals affected by this condition and reduce their dependency on other treatments. Gene therapy can enhance the body's natural defense mechanism, boost the immune system, or correct genetic mutations, thereby offering new avenues for treatment.
Gene therapy holds great promise. Somatic gene therapy has the potential to treat a wide range of disorders, eliminate and prevent hereditary conditions, cancer, and infectious diseases. The development of gene therapy is highly regulated by the FDA and National Institute of Health. Gene therapy is a rapidly evolving field. Recent clinical trials of gene therapy have shown remarkable therapeutic benefits and an excellent safety record. With gene therapy, doctors deliver a healthy copy of a gene to cells inside the body. Nearly 50 years after the concept was first proposed, gene therapy is now considered a promising treatment option for several human diseases.
Promise? What a big word, but usually causes disappointments, and promises meant to be broken. Yes, we cannot deny the fact that it really helped people to their severe illness, but is that 100% sure? Is there any patient that died due to the gene therapy? I believe that not all people can afford that, and also not all people are applicable to have a surgery because it might cause them severe allergies and everything that can trigger their implications. All I can say right now is that it's technically so dangerous. There is some concern that if gene therapy reaches other cells in body besides the faulty cell, it could have harmful effects. There is also concern that reproductive cells could be changed without protection, and this could be passed on to people's children. That's all I can say.
These kinds of talkings alarms me totally. We are talking about the lives that will be risked in taking this kind of modern medication, gene therapy, as it has issues that the side effects of this can trigger various diseases that the patient have. The dark side of this medication is very serious. It can lead to the person's life into his death. I believe that there are always ways to treat diseases that with caution and proven safety medicines. The government should take action and put funds for researching other treatment instead of wasting the time for a certain thing that is undoubtedly dangerous. The death of the 18-year-old volunteer in the clinical trial is enough reason to stop these practices.
Gene therapy has the potential to revolutionize the treatment of genetic disorders. Targeting and correcting specific faulty genes, it offers the possibility of providing long-term relief and improving quality of life, and even curing previously incurable conditions. This groundbreaking approach holds immense promise in alleviating the suffering of individuals and families affected by genetic disorders. That's why I really believe that there are so many advantages and benefits in gene therapy. Though through gene therapy, it becomes possible to identify and modify genetic predispositions to certain diseases and potentially preventing their occurrence in future generations. Gene therapy holds promise in treating genetic disorders.
The medical system of gene therapy corrects the harmful genes in multifactorial diseases is cutting edge and has the potential to transform how we treat illnesses. This strategy might be providing treatment for multifactorial illnesses that were previously thought to be incurable. What you need to know about the gene therapy and the potential benefits of gene therapy or the ability of gene therapy to heal hereditary or multifactorial diseases that have no known treatment is one of its most important advantages. By correcting the underlying genetic flow, gene therapy can offer many illnesses a long-lasting treatment. Additionally, by employing the genes that aid the body in fighting the disease, gene therapy has the potential to treat non-genetic illnesses like cancer. With continued research and development, we can expect to see significant advancement in the field of gene therapy and the potential for life-changing treatment.
Gene therapy is indeed a cutting-edge medical approach that holds great potential in revolutionizing the treatments of various diseases, including multifractional illnesses by targeting and modifying persons' genes. Gene therapies aims to correct the underlying genetic or defects or introduce therapeutic genes to alleviate or prevent the progression of certain diseases. Therefore, gene therapy holds tremendous promise in treating multifractional diseases and offering potential solution for conditions that were previously considered incurable. Continued research and development in this field have the potential to bring about groundbreaking advancement and life-changing treatments for a wide range of illness.
I believe that the process of gene therapy is still experimental and may possess a myriad of potential risks. According to Genetic Science Learning Center in 2012, one of them may include the targeting of the wrong cells that results in the stitching of a gene into an inappropriate location, disrupting another gene. An example of this is when 5 children with X-linked severe combined immune deficiency or SCID were tested between 1999 and 2006. Unfortunately, one of them died due to leukemia because the newly transferred gene disrupted the gene that helps regulate the rate of cell division. These raise important safety concerns in the area of gene therapy. Keim in 2007 states that success is not a word generally associated with gene therapy. It's even led to deaths that some experts believe should have never happened. Thereby, I stand that gene therapy can have harmful effects and it could even lead to heritable alterations in the genome that could be passed on to future generations rather than the effects being confined to one person. That would be all.
Gene therapy could harmful effects, but it has the ability to efficiently treat and even cure formerly incurable genetic illnesses, especially the high disruption of important genes in target cells. Is the potential to effectively treat and even cure previously untreatable genetic disorders. Millions of people and their families now have hope as conditions that were formerly thought to be permanent burdens can be treated at record cost. Gene therapy can now be used to target previously incurable diseases and restore normal gene function, potentially changing the disease completely. It will slowly growth of cancerous cells, stop their spread, and possibly even more them entirely. Gene therapy stands as shining example of how we can leverage our knowledge and innovation to improve the lives of countless people worldwide.
According to Pfizer, about 320 million people worldwide live with a rare genetic disease. Therefore, they pioneer breakthroughs that will change patients' lives. Gene therapy could enable patients to live without the need for ongoing treatments or the burden of daily disease management. This approach is very promising for treating a wide range of disorders such as cancer, cystic fibrosis, heart disease, diabetes, hemophilia, and acquired immune deficiency syndrome. It improved medical treatment considering the fact that gene therapy has the potential to replace and fix mutated genes and make disease cells more evident to the immune system. Apparently, gene therapy has a pivotal role in solving physiological enigmas.
A gene can't easily be inserted directly into your cells. Rather, it usually has to be delivered using a carrier called a vector. So most common gene therapy vectors are viruses because they can recognize certain cells and carry genetic material into the cell's genes. Potential risks could include certain types of cancer, allergic reactions, or damage to organs or tissues. And this technique presents an unwanted immune system reaction. Your body's immune system may see the newly introduced viruses as intruders and attack them. And this may cause inflammation and organ failure, and there is a chance that the insertion might lead to tumor formation. Therefore, gene therapy is not a safe medication. I believe that while gene therapy has its benefits, it can also definitely pose potential risks of discrimination against people based on their genetic information. Genetic discrimination occurs when individuals are treated differently based on their genetic information. This can include discrimination in employment, insurance, and other areas. In the United States in 2008, a woman named Lisa Dawn was denied health insurance due to her genetic test results that showed she had a predisposition to breast cancer. The insurance company argued that Lisa was at a higher risk of developing breast cancer and therefore posed a greater financial risk to the company. Moreover, Bonham stated that genetic information from gene therapy could be used to justify discrimination based on race or ethnicity. In any advancements, we must ensure that people will not be discriminated against in any form. And clearly, gene therapy will most likely open doors to bioethical issues and violate numerous human rights.
Gene therapy do not possess discrimination, wherein the benefits of this are that somatic gene and cell therapies are widely accepted morally, with bone marrow transplantation and gene therapy utilized to treat children with severe combined immunological deficiency. Genome editing is increasingly being employed in somatic gene therapy to treat and prevent disease. But recent breakthroughs have raised the prospects that genome editing might be used for objectives that other than gene therapy and other medical interventions. Bone marrow transplantation has been utilized for decades, and gene therapy is now being used to treat children with severe combined immune deficiency, wherein even children with such genetic issues aren't seen prejudicially.
Today, we gathered here to discuss a topic of immense significance: gene therapy in pediatrics and the ethical considerations and safeguards surrounding this revolutionary medical intervention. Gene therapy holds tremendous potential to transform the lives of children suffering from genetic disorders. But it is imperative that we critically examine the ethical implication and implement robust safeguards to ensure its responsible applications. First and foremost, let us acknowledge the profound ethical responsibility we bear when we dealing with pediatric patients. Children are inherently vulnerable and rely on us, as caregivers and decision makers, to act in their best interest when considering gene therapy. We must ensure that the potential benefits outweigh the risk and that the child well-being is at the forefront of our decision-making process.
Gene therapy holds tremendous potential to transform the lives of children suffering from genetic disorders. Also, children are inherently vulnerable and rely on us. But how can we assure that this gene therapy could have harmful effects in the body? Moreover, not all the therapy can help a pediatric child to prevent the disease, but there are still new approaches to treatment and may have risk. Also, it's too expensive to undergo this kind of therapy. Some gene therapies use inactively viruses to carry healthy genetic material into a faulty cell in the body.
Gene therapy in human beings raises a variety of important ethical, legal, and social issues. Somatic gene therapy or SGT is similar to other forms of medical treatment in that the goal is to treat or prevent diseases in individuals. SGT raises questions concerning safety and efficacy of treatments and protections for human research subjects. Germline gene therapy is different from traditional medicines because it involves manipulations of the human genome to prevent the birth of children with genetic diseases. Germline gene therapy has been much more controversial than SGT because it creates risk not only to patients but also to future generations, and because it may lead to genetic enhancement. Genetic enhancement raises a number of difficult issues, including the ethics of changing human traits, parental control over children's lives, exacerbations of discrimination, and social inequalities and eugenics.
It is true that access and distribution of gene therapy could lead to social inequalities, but it is also important to consider the potential benefits of gene therapy as well. So gene therapy has the potential to cure genetic diseases that have long been considered incurable. By providing access to gene therapy, individuals who suffer from genetic diseases could experience a better quality of life and potentially even be cured their condition. So this would be a significant step forward in improving healthcare and reducing healthcare disparities. And gene therapy has the potential to address health disparities that are prevalent in society.
As healthcare advances, so much the process that connect patients to the therapies they need. Each patient's path to treatment is unique. And because of our rapidly evolving cell and gene therapy industry requires an equal innovative partner, Emersus Virgin is committed to delivering solutions that enable this connection. Also, the next generation of advanced genetic therapies raises profound medical and ethical issues that must be thrashed out to ensure the game-changing technology benefits patients and society. A group of world-leading experts has warned.
As a rebuttal speaker, I'm here to object the statement of the opposition. My stand about the gene therapy, it is helpful and beneficial for the patients who have severe and life-threatening diseases such as cancer, diabetes, heart diseases, and etc. Although it is costly and may offer some potential risk to our health, but on the other hand, it may help us to cure, prevent, and evade such diseases by correcting the DNA or the RNA. According to Medline Plus, governance gene therapy techniques allow doctors to treat a disorder by altering a person's genetic makeup instead of using drugs or surgery.
The widespread use of gene therapy that resulted in undesirable changes to the human genome. Genetic therapies hold promises to treat many diseases, but they are still new approaches to treatment and may have risk. Potential risk could include certain types of cancer, allergic reactions, or damage to organs or tissues if an injection is involved. Potentially dangerous. There's some concern that if gene therapy reaches other cells in the body besides the faulty cell, it could have harmful effects. There's only concern that reproductive cells could be changed without detection, and this could be passed on to people's children. It discriminates against or invites discrimination against persons with disabilities, and it may be becoming increasingly irrelevant in some cases.
The concept underlying the original gene therapy approaches, some of which are still in use, is fairly straightforward. When a disease results from a missing or dysfunctional gene, deliver a functional copy of the gene into affected cells. Gene therapies use various strategies to supply cells with healthy genes, influence gene activity, or tweak the genome directly. Each of these methods has advantages and drawbacks, including treatment, duration, and potential side effects. This approach, the first to be tested in humans, equips affected cells with a working copy of the gene that is missing or malfunctioning in the disease, whereas this strategy can work for disease traced to a single genetic glitch.
I believe that genetic enhancements holds the promise of advancing individual capabilities and strengths. By manipulating our genetic makeup, we can potentially enhance intelligence, physical attributes, and emotional resilience. These enhancements can contribute to improved problem-solving skills, increase creativity, and better decision-making abilities. Genetic enhancements can address certain genetic disorders and predispositions. Through gene editing and therapies, we have the potential to eradicate inherited diseases that have plagued families for generations. This technology offers hope to individuals burdened with debilitating conditions, allowing them to lead fulfilling lives and contribute to society. Genetic enhancements offers numerous advantages and benefits when it comes to improving personal traits that correlate with social success.
Genetic enhancement may not always be effective at improving personal traits that correlate with social success. Firstly, the notion of social success is subjective and varies from culture to culture. Secondly, genetic enhancement can raise ethical concern regarding access and equality, creating a divide between the genetically enhanced and non-enhanced individuals. Additionally, genetic modification could result in unforeseen health issues that may not manifest until later in life. Finally, genetic enhancement could lead a loss of diversity and individualism, creating a society and cookie-cutter individuals.
Gene therapy is important in developing new and effective treatments for a variety of diseases. And the only way to receive gene therapy is to participate in a clinical trial. And when we say the word trial, it means to test, to assess its suitability, and it means it is not 100% safe, and this may turn into complications. Some of the potential risks of gene therapy is our body's immune system may attack the newly introduced viruses that cause inflammation and organ failure. And according to Gene Therapy Mayo Clinic in year 2017, if the new genes get inserted in the wrong spot in our DNA, it might lead to tumor formation. And this failure can bring life-changing complications to human life. Sometimes what we thought was good made our situation even worse.
Gene therapy in human beings raises a variety of important ethical, legal, and social issues. Somatic gene therapy is similar to other forms of medical treatment, and the goal is to prevent diseases in individuals. Gene therapy is different from traditional medicine because it involves manipulation of the human genome to prevent the birth of children with genetic diseases. Gene therapy has been much more controversial than somatic gene therapy. It creates risk not only to patient but also to future generation, and because it may lead to genetic enhancement. Genetic enhancement raises a number of difficult issues, including the ethics of changing human traits, parental control over children's lives, and discrimination and social inequalities.
Yes, gene therapy has shown promise in treating certain forms of inherited blindness and restoring vision loss. In fact, in 2017, the U.S. Food and Drug Administration, or the FDA, approved the first gene therapy for an inherited form of blindness called Leber congenital amaurosis, LCA. LCA is caused by mutation in genes that are essential for the function of photoreceptors cells in the retina. Gene therapy holds the great promise as the potential treatment of inherited blindness, and ongoing research is focused on further improving the safety and efficacy of these treatments.
I have to say that I disagree with the statement that gene therapy for inherited blindness has shown promise. While it is true that FDA approved that the first gene therapy for LCA in 2017, the overall effectiveness of gene therapy in treating inherited blindness is still questionable. While the approval of gene therapy for LCA was significant development, it is important to note that this treatment is specific to a particular genetic mutation associated with LCA. It may not be applicable to other forms of inherited blindness caused by a different mutation. The success of gene therapy as one specific condition does not guarantee its effectiveness to treating other type inherited blindness. Thus, research is indeed address the challenges and limitations associated with this treatment approach before gene.
Vector-induced viral infections are a serious concern when it comes to gene therapy. The mechanics of these vectors can cause adverse effects such as immune reactions or unintended gene mutations. In some cases, the vectors themselves can cause illness or even death. It is important to fully understand the function and mechanics of these vectors before using them in gene therapy. While the potential benefits of gene therapy are vast, we must also be aware of the potential risk. Careful consideration and ongoing research will be key to ensuring that vector-induced viral infections do not become a barrier to the success of gene therapy in the future.
Despite the promises associated with the use of viral vectors of gene therapy, there are also significant risks. One such risk is the possibility that the virus may recover its ability to cause disease once inside the body. Another is the threat of insertional mutagenesis when using the retrovirus. Because viruses can affect more than one type of cell, it's possible that the altered viruses may affect additional cells, not just the targeted cell containing muted genes. If this happened, healthy cell may be damaged, causing other illness or diseases such as cancer. So that I disagree to your statement because gene therapy have also a negative impact to our body. And that would be all. Thank you.
Gene therapy holds promise for treating a wide range of diseases like cancer. Gene therapy is a potentially beneficial cancer treatment. Nowadays, cancer is one of the main causes of death worldwide. According to the World Health Organization, cancer is the second leading cause of death globally, surpassed only by cardiovascular diseases due to the lack of early diagnosis and high relapse rate after conventional therapies. Chemotherapy inhibits the rapid growth of cancer cells, but it also affects normal cells with fast proliferation rate. Therefore, it is imperative to develop other safe and more effective treatment strategies such as gene therapy in order to significantly improve the survival rate and life expectancy of patients with cancer. The advancement in cancer treatments like gene therapy offer the possibility of more effective and long-term treatments.
Indeed, one of the things that gene therapy is able to treat is cancer, but it does not state that it can clearly cure it, but it is just a treatment to improve the body's ability to fight cancer. It may be proven that the therapy is progressing good for the past decades, but some is still in trials and there is a much higher risk if some of the drugs only have a short counted success rate. It is potentially dangerous as it might affect or reach other cells in the body beside the faulty cell, and it can cause tumor and infection that will lead in worsening the patient's health. Lastly, gene therapy is still an experimental treatment in the field of medicine, and there are still things that we don't know about, and there are no guarantees that it will be successful as it still needs to be proven with evidence.